Welcome everyone. Today we will address one of the most strategically critical issues in food engineering, waste management within regulatory and circular economy frameworks. For decades, food engineering focused primarily on process optimization, thermodynamics, fluid dynamics, microbiological safety, and yield maximization. However, the post-consumption phase and residual streams were often treated as secondary operational concern. This perspective is no longer sustainable. Under the EU Green Deal and emerging national compliance schemes, waste is not merely a disposal issue. It's a regulatory, economic, and technological variable. Improper handling can generate legal risk, financial penalties, and environmental externalities. Properly engineered, the same stream can become a secondary raw material, bioenergy input, or value-added byproduct. This presentation will examine regulatory compliance mechanisms in waste disposal schemes, integration of circular economy principles into food systems, and also technical pathways for transforming waste streams into measurable economic and environmental outputs. Here you can see how this model reframes food waste management as both as a regulatory responsibility and a strategic opportunity within the circular economy. It integrates legal frameworks, recovery technologies, and management systems to ensure cost-effective, sustainable, and hierarchy-aligned waste solutions. Here you can see the measurable learning outcomes of these courses. By the end, you will be able to move from legislative analysis to technical process management and compliant reporting within an integrated waste management framework. It's the technical focus of today's session and the structural scope of our discussion. We will examine how regulatory compliance, biochemical recovery process, and operational control mechanism can be integrated into national and European food system within a circular economy framework. France. Paradigm shifts in engineering are rare but create an earthquake effect when they happen. We are currently at the epicenter of that earthquake. Remember the traditional take, make, dispose model to linear economy. In this model, we produce, the consumer consumes, and everything left is left to nature as an external naturally. But what does the first law of thermodynamics tell us? Energy cannot be created or destroyed, only transformed. For years we disposed of matter, but we actually just moved it and often put it in the wrong place. We are now in the circular economy era. Here our magic word is valorization. For a food engineer, waste is actually a design flaw. There is an output that cannot be used at the end of your process. It's proof that the resource entering the system was used inefficiently. Our goal is no longer to design a cradle to gravy life cycle, but a cradle to cradle one. That is, a tomato peel should go from the paste factory, not a landfill, but to lycopene extraction or a biogas plant. Look, even the term waste management is become outdated. We are actually doing resource management. As I said in the slogan, waste management is not a logistics operation. It's resource efficiency engineering. If you are just loading your waste onto a truck and sending it away, you are essentially throwing money and molecules into the trash. The main idea of this slide is waste is a resource in the wrong place with an unidentified identity, and your job as engineer is to give the correct identity. Now let us move to the regulatory dimension. For any company trading with the European Union or aligning with its standards, the Waste Framework Directive defines the constitutional structure of waste management. However, the rule should come with to 2025 revisions. Waste reduction is no longer voluntary, it's a binding. Under the update framework, a 10% reduction in manufacturing and processing and 30% in retail and consumption has become a legal obligation for member states and alignment countries. This means that every kilogram of loss is no longer only a cost efficiency issue, it's a compliance risk. In parallel, the farm to fork strategy extends responsibility across the entire value chain, from field losses to processing waste to retail shrinkage. Supply chain opacity is no longer tolerated. Data transparency and measurable reporting are mandatory. Tourism-related fluctuations may be adjusted through correction factors at national level. However, internal process inefficiency remains entirely within the operator's responsibility. In short, waste management has shifted from a sustainability narrative to a regulatory accountability framework. In Turkey, for those who think things run rosily here, I suggest examining Environmental Law No. 2872 and the recent HACCP invoices. Turkey's zero waste policy is not just about putting colored boxes in public buildings, it's an industrial transformation program. The most critical engineering parameter here is HACCP. This is a version of the polluter pays principle that touched our wallets. Look at the 2025 figures. You have to pay approximately 570 kurush per kilogram for plastic packaging and 670 kurush for vegetable oils. As a food engineer, 1 gram lightweighting study in packaging design or the use of recyclable materials can provide your company with millions of lira in tax advantages. R&D departments used to focus only on the shelf life and taste of the product. Now, the finance department will knock on the door, on your door and ask, can we lighten this packaging by 3 grams? The HACCP bill has swollen a lot, so legislation has become an economic instrument that directly affects engineering design parameters. Waste management in Turkey is no longer the monopoly of environmental engineers. It's a mad problem that must be solved at the common table of production, quality and finance. And remember, every waste undeclared or misdeclared returned as massive fines. Waste hierarchy. Here is the waste hierarchy, which we can call the 10 commandments of waste management. This pyramid is not just an aesthetic shape, but a legal decision-making matrix. When waste occurs, you have to ask from top to bottom. First, prevention. The best is for waste not to occur at all. Inventory management, demand forecasting, shelf life extension. This is our mastery area. Destroying waste before it forms means negative carbon emissions. Second, reuse. Food is for human, like Migros, respect for food project, delivering unsold but edible food to people. Third, recycling. If human can't eat it, let animals eat it. If that doesn't work, let it feed the soil with composting. And fourth, recovery biogas block. This is in fourth place. So saying let's throw it all into biogas is actually an admission that you failed the first three steps. And disposal, landfill or incineration, this is an engineering failure. EU and Turkish legislation have made this so difficult that it's now almost forbidden. Anaerobic digestion is the star technology of food waste. It is the process where a microbial consortium converts organic matter into methane gas and digests it in an oxygen-free environment. But this job isn't done by just filling a tank with trash and closing the lid. An anaerobic digestion reactor is like a pet with a very sensitive stomach. If you feed it wrong, it dies. You can see here two critical process parameters. You can examine what is the solution. Co-digestion is the solution. Preparing a cocktail by mixing food waste, not alone but with carbon-rich agricultural wastes like straw. It's one of the solution. Nestle's chocolate soup example is exactly this, balancing the waste recipe with engineering intelligence. If you don't have to investment to build biogas, we have alternatives, compost and feed, but there are regulatory red line here too. We can talk about industrial composting and upcycling to feed, and you can see here this subject. Waste management is not just an environmental issue, it's also a food safety issue. As a food engineer, you cannot think of your HACCP plan independently of waste. Waste is the biggest source of microbiological and physical hazard in your factory. We can talk about zoning, no backflow and coloring about this subject. Zoning, the door where clean product enters and the door where trash exits should never be the same. If waste and product path intersect in your flow chart, there is a serious prerequisite program error there, if not a critical control point. No backflow. Personnel or forklifts going to the waste warehouse cannot return to the production area without disinfecting their wells or boats. Even airflow should not be from the waste room to production. It's negative pressure. Coloring coding, this is simple but life-saving. If waste bins are red, no one accidentally puts raw material in them or carry raw material with that bin. The cheapest way to prevent cross-contamination is paint and training. When to HACCP auditor come, one of the first place they will look is your garbage room. If it's orderly, the perception is that the kitchen is orderly too. ISO 14001 is not just a certificate to hang on the wall, it's the operating system of waste management. We need to distinguish two concepts here, aspect and impact. Aspect is what you do. For example, discharging high organic loss water from the cleaning plant system to the server is an aspect. Impact is the result is created in nature. The planting oxygen in the water and killing fish is an impact. Your duty as an engineer is to visit every valve, every conveyor into factory and create a register. You must keep to answer to how much waste does this machine produce while running. Where does this waste go? Into register. Our slogan is clear: you cannot manage what you do not measure. You cannot improve what you do not manage. If you don't know how many tons of organic waste comes out of your factory per month and how much of its water and how much is dry matter, you can neither establish a biogas plants nor submit a correct HACCP declaration. It's no longer enough to say we are environmentalists. You have to prove it. The EU's Corporate Sustainability Reporting Directive and ESRS E5 standards strip companies bar. Welcome to the age of transparency. The most important engineering tool we will use here is mass balance. Raw material entering is no. Product existing is no. Where is the difference? Waste, evaporated, water, or loss. If you cannot set up this equation and report 5 tons of my 100 tons of raw material become waste, I sent 3 tons of this to feed, 2 tons to biogas. You cannot access green credits. Your score on the stock market drops and your customers, especially EU retailers, remove you from the supplier list. Data management is as critical as process control. Being able to distinguish between hazardous and non-hazardous waste with data save your life in audits. Theory is nice, but practice teaches. Here is a fair example that will make you say, wow. First, Nestle, an engineering marvel project, chocolate soup. They mix faulty production wafers, confectionaries, and washing waters to make a chocolate soup. They fed this to the anaerobic digester inside the facility. Result: 10% of the factory's electricity needs come from its own trash. They get rid of both waste disposal cost and the electricity bill. Second, Danone, to world's first carbon neutral baby formula facility, they use a biomass boiler and work with the zero waste to landfill principle. Every waste produced is recovered in some way. And third, Migros is in Turkey, in our country. AI supported demand forecasting. As we said, the best way to manage waste is not to create it, and Migros does this with algorithm. Also, with respect for food, they withdraw products approaching their expiration date from sale and donate them. This is both social responsibility and waste cost management. We have reached the end of the presentation. There is only one thing you should keep in mind when you live here. Legal compliance is just a ticket to enter the game. The real goal must be valorization. The food engineer of the future is not just the person who makes delicious yogurt. They are the person who recovers every molecule left over from the production of that yogurt back into the circular economy. The red map before you is clear. 1. Measure and analyze waste at the source. 2. Memorize legal limits. 3. Choose technology wisely. And 4. Integrate the system with HACCP and ISO 14001. Remember, waste is not a problem, it's the fuel of the circular economy. If you act with this vision, you save both the planet and the company's balance sheet. Thank you for listening, and bye.